Okay, so I am starting to share my presentation. Is my presentation visible to everyone?
Yes.
Is my pre Okay, all right, that's good. So last Wednesday, I uploaded a video as well as this is Banstola. Ashish ji, please join on time. So so on Wednesday, I just created one notebook file and I uploaded to Google Classroom, right? So today I will show you how that file can be reused through Jupyter Notebook. So let me open this Google Classroom. So you might be aware of this, but some might still do not know about this. So I will just show you how to upload or how to download this this Jupyter Notebook file and use it in your own code. So where was that? Modules and functions, Python data types, Conda environment, object-oriented programming. Okay. So here you can see one file. That file is, this is the file that so this is the file I wrote the code in. So I have just uploaded this to Google Drive, Google Classroom. Just I want to download this file. I clicked on download and this is where my file is downloaded. Okay, this is my coding file that I last wrote. Okay, this file is downloaded and now I would like to view this file into my own Jupyter notebook. So for doing this thing, what I have to do is, let me start Jupyter notebook. I'm going to start Jupyter notebook. Okay, so this Jupyter notebook is open and you see this user interface. Then what I have to do is, I just have to upload this file. Like here we have a menu, we have a button called upload. Just click in this upload. Then we need to select that file. Here is our file, object oriented programming ai.ipynb, and just click here on open button. The moment you do this, it will automatically upload this file to here in this directory. Now where is that file? We need to see it. Okay. I say search objct object. Did it upload it? Let me modify it. Search with it last modified. I don't think it is uploaded maybe. Let me try once more. Object-oriented programming. Just try it. I uploaded enter button. maybe this has problem. So let me open this in Google Chrome. Sometimes this does not work well. This Internet Explorer does not work well. So let me upload this file from Google Chrome. So here, when I say open, then it is asking for upload button here. Like the file here, this file has come here, and you just have to click on this upload button. Click in upload, and the file is uploaded. Now, when you check this file, with last modified, here it is, this file, object-oriented programming with AI.py. Now, when I click on this file, it will open into Jupyter Notebook. And you can see all this code, whatever I has written on last Wednesday. So this is the class that I wrote on last Wednesday. Okay, so I just wanted to show that if I have shared you file in Google Drive or Google Classroom, here, when I share this file, you can just download this file and you can see this file and watch whatever is the code here and all those things. Okay. So, just a review of last week. So last week we talked about object-oriented programming, where we talked about what is class and what are methods of class. Then we talked about what is object and how can we define or call object. What is inheritance? How can we define child and parent classes? So as you can see, the class is simply defined by the CLAS class construct, where we give the name of class, simply like we created human class with class and class name human, and then followed it by two brackets. So this two bracket is not necessary if you do not have child class. If you do not have child class, if you are not child class, or if you are not inheriting any properties of child class, so this double bracket is not even necessary, but it won't matter. So then we have here init method. So this is a by default method of Python, which is used to initialize an object, or which is generally used to construct an object. So here in this is just a specified syntax. You just have to write like this: specified keyword, ini underscore underscore init underscore underscore. Then self is also a predefined keyword, and you have to write here whatever is the variable name or parameter name. So what you are doing here, all you are doing is just you are creating a property named at weight and storing it. So how can you store this weight property? Using self keyword, self dot weight. So self represents nothing but an object instance within a class. So then we have defined another method, memory unit, where we have self and person name as a parameter, and we are just printing this method. So this is just the template or class we created like this. So this is defining what is the structure of this class and how this class is defined. Then what we are doing is we are just creating an instance of a class. Like for example, we are creating an object named as prey, which is of type human, and we are passing here 72 as a weight. So that means to say, when you say prem equal to human of 72, the call directly goes to here, and the my weight gets the value of 72. Then we are saving this 72 value in self.weight variable. Okay, Then in the same way, we are calling another method like frame object. There is a frame object, and we are calling this another method memory unit frame dot memory unit frame. Here we are passing the method name as frame. So sorry, name as frame. So that means to say this frame is something gets reflected here in person name, and just we are printing this. Just we are printing this message. So this was our simple class. So then we talked about the inheritance. So how the parent class can, how the child class can get the properties of parent class. So when talking about that, we we have the human class as parent class, and then we defined an American person as child class. So American, when we say American person is a child class of human person, we define, we write this like plus then American person. Then inside this, we define the tag this human. So this human means nothing but the class name of parent, the class name of parent. So that means to say class American person. It is of type human, and this is again we are defining defining a constructor or initializer, which does nothing but create an instance. Whenever we call this, whenever American equal to American person, whenever we want to construct an object, so initially this method will automatically be called. So this is initializing. How what it is doing? So American person is passing two parameters. One is weight and next one is height. This weight and height we are saving into this self variable, self dot American height equal to American height, and again this weight variable, weight value or property we are sending or passing to our parent class. This super is telling, the super keyword is telling that we want to initialize. Super dot init is telling us that we would like to initialize parent constructor. So that means to say whenever we do super dot init, so this call directly goes to here. So here, super.init means directly the call passes from here to here, and the weight here gets reflected. Then weight is saved into self.weight variable. Okay. So super.init means to say it is directly calling the parent class. So parent class is nothing but human class. So the call directly goes here. So all you have to understand here is you just have to understand the flow. This is just an structure. It is doing nothing. This is just an structure which is defining a human class where human has two methods. One is the initializer, that is creating an instance or object, and next is an another generic method memory unit. So you can have any number of methods here, right? So the main thing to understand here is how the class gets, how the object communicates to its class. So for example, whenever we would like to create a human, like say frame, we just have to create an instance using this human class name, and within bracket you just have to pass the value of this 72 as per parameter. Like if we do not give this my weight, if we remove this my weight parameter, then we don't need to pass this 72 also. So that means to say it is by default accepting no parameter. But here it is accepting a single parameter. So this is known as parameter. Okay. So then we are calling another method. So to call any method, so we just do using the object name dot method name. We do that, and it will call object method. So this was just a review of last class. Uh, and then after, so today let's do something else. So something else is I would like to introduce you one of the important library that is used for scientific computation and machine learning. So that library is known as numpy. numpy numpy numpy. So numpy is nothing but numerical Python. It is simple form. It is short extension for numerical Python. That means to say, uh, we use numpy to compute most of the things, most of the mathematical calculations uh, in Python. So this is just a library. So as it is library, it is not by default found in our Python. So we need to install it. So how can we install it? So let's say we, so for installing this, we can just open our command prompt such as anaconda. We open this anaconda, and here we are in base package, and just we'll check whether this is already available or not. So as if you install anaconda, by default numpy package is installed, but if you are not using anaconda or you are just using plain python, then you might have to install it manually. So in conda, you just have to, if you have to check whether this numpy package is available or not, simply type conda list numpy. So it will check if numpy is available in your anaconda library or not, if conda. So here you can see, so it lists the packages. So numpy is already there with version 1.2.1.2, 1.21.5. Then there is numpy based package is also there with version this one, and numpy doc. This is for numpy documentation. So you already have numpy. But if you do not have numpy, what you have to do is you just have to type anaconda command or pip command to install this. Let me uninstall this first. For example, conda uninstall. If you have to uninstall this, you just have to type conda uninstall numpy. So it will uninstall the numpy. So remember that for doing this thing, you just need an internet, because whenever you try to install numpy through this command line, so it will download the packages from internet and then install. Okay, let it uninstall for some time, and till the time we will look at numpy. So as I told you, uh, numpy is basically used for mathematical computation or numerical computation. Mostly numpy is typically useful for handling multi-dimensional arrays. So multi-dimensional arrays means to say, like for example, if you talk about single list, if you talk about the single list data type, so that data type is nothing but single dimensional array. List is single dimensional array. Then when you talk about the matrix is nothing but it consists of number of rows and number of columns. So that means to say it is two-dimensional array. And when we may have three-dimensional properties like for example image or something like 3D structures, house, something like that, x y z coordinates, wherever there are. So these are three-dimensional arrays. But in artificial intelligence, whenever you have to deal with data, you have to deal with multi-dimensional properties. Like for example, there might be dimensions with thousands of dimensions. There might be dimensions having more than thousands of dimensions. Like how so to deal with those high dimensions or multi dimensions, it is very difficult to compute those features using simple plain python. So python cannot handle those multi-dimensional arrays efficiently. So if you have to compute or do certain kind of numerical computations using uh, in such a large dimensional arrays, or if you have to compute the values, if you have to compute the mathematical operations fastly, normally Python is very slow in achieving that. So This numpy, there is a numpy library built on the top of Python programming itself, but it is very fast. Why it is very fast? It is very fast because it has optimized the computations. It has optimized the computations by doing parallel computations, or in other words, if you say in other words, by vectorization. So this is just uninstalling, let it uninstall. Okay, here it has given a typical example. For example, 1000 cross 1000 matrix multiply. If you have to multiply two matrix with 1000 cross 1000 dimension, 1000 cross 1000 dimension, so it takes a Python takes almost the Python using loop for computing the matrix, it takes more than 10 minutes. But if you do the same thing using numpy, so it takes around 0.03 seconds only. So numpy has efficiently built, numpy has been efficiently built on the top of Python programming itself. uh, the faster computation, it executes the faster computation, so due to the fact of vectorization. So vectorization means nothing but a way to do parallel computation. So where you can have, like for example, whatever can be multiplied or summed at one time, that can be parallelly multiplied or summed. So basically, mostly what we use in artificial intelligence, what we use in data science, uh, the use of numpy in data science is mostly based on arrays. Like most of the time, what we require to do is we have data sets with multiple dimensions. Like the data set may be having more than 5 or 10 dimensions, such as, for example, if you simply talk about the images, if you are doing computation on the top of images, and image is nothing but three-dimensional file. So which has its width, its height, and then its channels, RGB channels. For example, RGB means to say red, green, and blue. So, or as image, an image is a three-dimensional structure. So in NumPy, what we do is we perform most of the calculations. We read those data structures into these arrays, and then we reshape those. We reshape those. Like for example, to convert three-dimensional structures to two-dimensionals, or to convert multi-dimensional structure into another multi-dimensional structure. So we may often require those kind of things. Then we sometimes also require mathematical operations like multiplication, summation, all those things we perform using NumPy. So why we do need this is because, so performing large number of mathematical operations in Python is little bit slow, very slow, and NumPy optimizes it. So then indexing and slicing. So to extract some particular chunk of data set, let's say let's say I have array of index from 1 to 1 lakh. Then if I have to extract the indexes, or if I have to extract the data from 1000 to 10,000 only, so how do we do that? So NumPy can easily do that. Also, next thing is like broadcasting. So broadcasting means to say to perform a common operation across each of the element. Let's say we have a matrix of 3 cross 3, and we want to add 3, number 3, to each element of an matrix, of a matrix. So how do you do that? So this is all about broadcasting. Okay, so here we see the NumPy has been uninstalled, and if I have to install NumPy, then what I have to do, it is very simple. Just type conda install numpy, it will install numpy by default. What is the currently operating version of numpy, it will install. So if you have to install some specific version of numpy, then you have to check which version of numpy is already available. Based on that, you just have to install like this, numpy equal to 1.14. If you tell like that, so it will install a specific version of numpy. Otherwise, if you do this conda install numpy, it will by default install the default version of numpy. Let me go, sorry, yes. So let me install this numpy conda install numpy. So when I do that, it will install the numpy. So let it install till that time we see something. So before understanding artificial intelligence, so you need to understand about the few basic concepts like what are vectors, what are matrices, what are images, what are tensors, and convolution nets. So when you talk about vectors and matrices, so vectors, try simply understand, do not complicate the things, simply understand vectors. Like vectors are nothing, but you can just imagine vectors as a list. So if you have good concept on vectors, so you know that vector has some specific directions with some specific values, scalar values. So just to simply understand, as of now, just simply understand vectors as some specific points, some specific list of numbers. So just like that, you just understand like p, x, p, y, z. For example, a vector of 1, 2, 3, the number of 1, 2, 3. So this is something like a column vector, single column vector. You can think it as single column vector. So that is known as column vector, or there is something known as row vector also. So then matrix, we have matrix. So matrix is nothing but combination of vectors. When we have multiple vectors, vectors at one place, so that is known as matrices. So vectors and matrices are mostly the most fundamental parts of AI building. So these will be used for your numerical computations. Whenever you have to manipulate the data, you have to reduce the data. So your data might be having hundreds of or thousands of dimensions. And from that thousand dimensions, you would like to reduce dimensions to two dimensions using some mathematical operations and perform certain tasks over the top of it. So you need vectors and matrices. So all of your data manipulation operations are solely based on nothing but vectors and matrices. So these are the most fundamental things. Like what is the like if you are talking about the bridges, let's say what a bridge uh what a bridge can how much a bridge can handle a load, or what is the torque, what is the force applied on the bridge. So all those things can be just systematically or mathematically can be arranged in vector type of data structures so that we can perform certain specific mathematical operations on it. Then we have the images. So in artificial so mostly nowadays images are the most popular thing that we perform manipulation. So images for like when we talk about certain things like face detection systems, or whatever it is you see nowadays, like object detection systems such as whether this is cow or whether this is dog, or object detection or object labeling systems like to identify what type of object it is. So all those things, we have this raw data where on the basis of this raw data we train our artificial neural networks and builds perform computations. Then we have tensors and convolution net. So tensors are nothing but multi-dimensional data structure. Like normally matrices is like 2Ds. But what if there are so many dimensions, like so many infinite dimensions, simply like infinite dimensions? You can think of like many dimensions. So how do you do that? So that those type of computations are done using these tensors. And this convolution nets, so convolution nets are nothing but when you have large data sets, you convolve this. When you have large dimension of data set, So you convolve that into smaller and smaller and smaller. You do different kind of manipulations. You filter it, reduce it, and you filter out and get most out of the most important concept or most important part out of it. So those are convolution nets. Okay, so I want to install numpy and let it install. So this numpy is installed, and this numpy is in our base environment only. In our base environment only, and let's execute this simple numpy function. So for executing numpy function, we need to have import. We need to import first a numpy library. As with this command import, you may be familiar with this import command. So import, you have to do, you have to tell this package name, import numpy package as np. Np means nothing but aliasing. Aliasing means instead of telling numpy, you can just refer this as np. So this is np is nothing but you can think it as an object. So whenever you would like to call the properties, whenever you would like to call the methods of this numpy class, for example, if it is numpy is a class and there are many methods such as array to create an array, then a.ndim, number of dimensions. These are the properties, like properties or attributes. Ndim means number of dimensions. How many dimensions are there? Shape. Shape means what is total shape? What are the number of rows and what are the number of columns? And what is the data type it contains? So these are all done by numpy. Okay, so let us check this. So let me create some new file. Okay, so let me create this notebook in my own. Okay, so this is my, let me say numpy example. So here I will tell you one thing also. For example, you want to check whether this, you want to check if this Jupyter node, if this environment has numpy or not. So you don't want to use this command line, but you want to check from here that whether numpy is available or not. So you, before doing that, you just, what you can do is you just execute this like this. Not conda list numpy. Let me check what happens if I execute this. Okay, so it shows me something like it shows there is already a numpy 1.2.34 and this numpy base with 1.2.34. So that means to say now I have a numpy installed with 1.23.4 version. So whenever you can also execute commands, conda commands, or any command through any command that you can execute through this command line. But what you have to do is you just have to put this exclamation mark, not. If you put this exclamation mark, so you can just execute any command, whatever you would like to execute. Okay, so as we know, we already have numpy here installed. 1.2.1.23.4 version of numpy is installed. Let me import this numpy. So how can I import this? I will say import numpy as np. So np means nothing but aliasing. So I will execute, I will run this cell. If I hit shift enter, so it will execute the cell, and it will execute the cell. And if numpy is not available, it will give error here itself. It will tell some message. It will tell something like no package found or something message it will populate. Otherwise, it will give no error and it just executed. Okay, let me check numpy dot.
Hello.
np dot. Yes.
Yeah, is it also available in Google Colab?
Yeah, this will be available in Google Colab also. Yes, it is the same. It is
But
the same.
I but for Google Colab we should also install it by command prompt.
Yeah, by default, so Google Colab is enabled with numpy package, matplotlib package, and most of the scientific computing packages. So if it is not available, you just have to install it like this. Not conda install something. Okay. So using
Not
this, you just
no,
have to
actually
do.
I was using this command not conda list numpy. Then I got a message conda list empty. No, conda list numpy is a command not found.
So
This
maybe there is.
command not found.
Let me check. I don't think that it would work like that. Maybe not conda list numpy. Okay, this is my Google Colab platform. Yeah,
Yeah,
I think
just
this
in
is
that.
simple. This is simple Linux shell only, so you don't need this not. Simply to work. Maybe Python kernel does not appear to be in conda environment. Okay, okay. So this is, I think it is not in conda. So because of that thing, it is giving this error. So this might be running in pip version itself, I think. So that is not working. Like pip list numpy. Yeah. So I think this is working with pip. So there is something known as pip also. So this is working in pip environment. Pip package. This is working with pip. This Google Colab is working with pip. Pip list. Okay. So just you try with this one only. Okay. Anyway, you don't need to try that also. So if it is by default already available in this, numpy is already available in this Colab environment. Okay. Then this we imported this numpy. We imported this numpy as library, and now we would like to, let's say we would like to create an array. So to create an array, let's say I would like to create one two-dimensional array, saying that np dot my array. I would like to create an array with name my array. So how can I create this? I have the method like np dot arr, np dot np dot array, np dot array. Then you have to do this bracket. Then inside this, you just have to type this double bracket. Within double bracket syntax, you just have to write like 1, 2, 3, 4. Okay. So when you do that, you just execute it. If there is no problem, it will give no problem. Okay. So it created an numpy array. It created a numpy array. Let us check the shape of this numpy array. So when you say my array dot shape, so it will give this. So what it is telling? It is telling that this numpy array has a shape of like 4 elements. There are 4 elements within this. So that is why it is telling 4 comma, so 4. It is telling 4. So let's make it two-dimensional. So how can we make this two-dimensional? For making two-dimensional, we just have to add this additional bracket. Let's say add 2 bracket. So this means say now it is two-dimensional. Okay. Now let's execute it with control enter and then again check the shape. Okay. Now when you check the shape, it told us that it is of shape 1 comma 4. So that means to say we have one row but 4 columns. The shape of this is one row but 4 columns. So let's add one more element inside it. So for adding one more element, we just have to do comma. So again, let's say 5, 6, 7, 8. Okay. So we did like this. So now what is the shape of this? So that means to say this is first row, then this is second row, right? So that means to say there are two rows, and in each row there are four columns. So that means to say this array should have a shape of 2 cross 4. Let's execute this and say, now it says this array has shape of 2 cross 4. Okay, it gave us the shape 2 comma 4. That means to say we have and 4 columns. So it might be also 3-dimensional also. Let's say, how can we make 3-dimensional? For making 3-dimensional, what we have to do is, for each element, for each x there is y, and for each y there is z. So something like that. So to do that, let me say, if we add one bracket more, and if we add one bracket more, now if we just check this, it is 3-dimensional. Now what is the dimension of this? So this is something like 1 comma 1 cross 2 cross 4 dimension. So how it is that? So that means to say there is one single row, there is single one row. Within that there are two columns. So that means to say there are two columns. Like one column is this, and another column is this. And then within that we have 4 elements in each, right? So entirely there is one row, then two small columns, and then inside that there are 4 individual elements. Okay. Now if I add one more element, let's say if I add one more element inside this, let's say 9, 10, 11, 12. Now when I say that, now what is this? There is entirely one row, then there are entirely 1, 2, 3 columns, and within 3 columns also there are 4 elements in each. So that means to say 1 cross 3 cross 4. This, the shape of this is 1 cross 2 cross 4. Now if I have to add 2 rows, so that means to say, I'll just to say this is the first element, and I would do comma, and then I would say second element. Now what it will be? So it will be of like 2 cross 3 cross 4. Okay. Now you understand this. This is multi-dimensional array. So the realization of this and going beyond 2 dimension, going beyond 3 dimension is very difficult, and very difficult to understand and interpret. But you just understand the concept that how these things are manipulated and done. So that is the thing. So when we tell like this, so here is something like we just initialized an array, then we just checked what is its data type and how many dimensions are there. So if I have to check how many dimensions are there, let me check. This is in dim keyword. So it says there are 3 dimensions. Okay. Right. So this is then 3-dimensional thing, x, y, and z. So this is just a 3-dimensional array. N dimension, number of dimensions are 3. So this is this. Okay. So this is number of dimensions. And if I have to check the type, if I have to check the type, what is the type of this array? So let's say D type. When I say D type, data type, what is this data type? So this data type belongs to this int 32. So remember that Python data types and these numpy data types are entirely different. So, but however, numpy data type and Python data type are compatible in nature. For example, int, for data type of int in Python, there is int 32 and float 32 and something like that. For detailed instruction and what are the data types and all, if you just Google numpy data types versus Python data types, when you say this, you will get plenty of things or manuals as well. Like here you have this something. Like here there is Python type int, numpy type int 8, int 16, int 32, int 64, something like that. Float. In Python there is a data type something known as float. Then in numpy there is float underscore, float 16, float 32. For boolean also boolean underscore, something like that. So this is something like that. Okay. So you can even specify the type of the data. Like for example, if you have to specify the specific type, let's say I want to create this type. So by default, this is of type int 32, but I want this data type to have to hold the value specifically to hold the value as float. If I want that, then what I have to do is I just have to specify the type here, like using do comma. So what I will tell numpy dot type, numpy dot d type. D type means data type equal to, then what you have to do, numpy dot np dot, or simply you can tell np dot float 32. So it will by default convert this data type to float 32. Now the data type is float 32. Now if you have to check how many elements are there or something like that, for example, you simply do this. Now it has converted this data into float. So that means to say 1.2.3.4.5 points, even if it is nothing, but this has converted this our numbers into float. So why we need by default numpy? By default, there are computations, all those computations, numerical computations in artificial intelligence in real time or in practical sense will all be based on this float data types only. So most of the computations will fall under this float data type. Okay. So like there are many utilities functions like you have to create numpy dot once vectors or zeros vectors or something like you want to concatenate add two arrays or do some things like that. So how can you do that? You can do that easily using numpy. For example, let's say I want to create zero matrix. I want to create some, yeah, maybe zero matrix or something like that, zero matrix, let's say. So what I will do, for example, mat my matrix equal to np dot, I have a function something known as zeros, np dot zeros of, let's say, then here I have to give the space. Let's say I want to create a matrix of 3 cross 3. Okay. So when I say that and when I print this my underscore matr, so it give me numpy dot zeros of 3 cross 3. So if I check the save my matr my matrix dot save, so what it will give me, the save of this array is this something like that. Similarly, if I have to create the matrix of ones, so there is function like numpy dot ones. So when I say 3 cross 3, or you can say like 4 cross 4, or you can say like identity matrix of, for example, vector only. If it is, let's say, vector only 4, numpy dot 4 comma 1. So this is a two-dimensional two-dimensional 2D structure with 4. Let's say I want to create single dimensional vector np dot one sub 4. So that means that this is single dimensional, or this is a vector, this is a vector, or this is a row vector with 4 number of ones. Okay. So similarly, if I want to, if I want to print out the range or range, then how can I do that? Range means to say, let's say np dot or range np dot or range of, let's say I say 3 comma 4, what it says, I don't know. So this is not the syntax. np dot or range of let's say 0 comma 10. So when I say np dot range of 0 comma 10, so it populated values with 0 1 2 3 4 5 6 7 8 9 from 0 to 10. So what it did was it does not include the last item. So this is inclusive. Starting point is always inclusive in nature, and the ending point is exclusive in nature. So that means the ending point is not included and the starting point is included from 0 to 1. So whenever you have to create this type of structures, so you can do like this. So if you have to concatenate two arrays, let's say you have the arrays, let's say you have an array A with np dot zeros of 1 comma 3 or 2 comma 3, and B with arrays of np dot, let's say A is there and B is there with np dot ones of, this was also the similar type of structure like 2 comma 3. Okay, this is B. Now if you would like to concatenate these structure, now when you are concatenating or when you are adding this thing, so always you have to remember that whether both of the arrays or both of the matrix are compatible or not. So you just have to understand that. Otherwise, if those are not compatible to do certain kind of joining, then it won't be joined. Then say let's say concatenated matrix equal to np dot concatenate. Then what you have to do is inside that we have to give just a comma b, and when you do that, if you do this, what happens? Concatenation of np dot concatenation something like this. Invalid center. Concatenate. Concatenate. What is its syntax? Concatenate. The syntax was good one, but maybe this is old documentation. So concatenate, numpy concatenation, np dot. Okay, the syntax is like this: np dot concatenate a comma b. So what we did here, numpy dot concatenate, not like this. The syntax changes with time also, with version also they change things. So sometimes the things that were working previously does not actually work.
There is extra n there. So concatenate. There is no
Concatenate.
n.
Okay. Okay, like this, so it can be concatenated. So you have to understand one thing also here. So you can concatenate it through row wise or through column wise. So when you say x is equal to 0, by default it will concatenate through the row wise. Row wise it will concatenate. Or when you do x is equal to 1, it will concatenate through column wise. Okay. You understood what I told? X is equal to 0 means say it will concatenate through row wise. That means to say, for example, here I have two rows, right? Here we have two rows. Then here I have two rows. When I am combining A with B, so two rows, these two rows, and then below two these. So that means what happens? Two rows and two rows. Then it becomes like four rows, like this, right? So, but when you do x is equal to 1, when you do x is equal to 1, it will concatenate across the column. So that means say first column, second column, third column, first, then fourth column, fifth column, sixth column. So it will come like this. Okay. So this is very important to know. So when you do concatenate, when you are adding, sometimes you need to add or concatenate through row wise, and sometimes you need to add or concatenate through column wise. So most of the time you need to concatenate through column wise, because you just wanted to so you just wanted to so what you wanted is you just wanted to include a feature or reduce the feature, something like that happens. So for doing this thing, for example, let's say you are getting data from Excel sheet, Excel columns, and you are getting data from one Excel sheet, and you are getting next data from next Excel sheet, and you want to concatenate data based on both of the Excel sheet. So how can you concatenate this? You can concatenate this based on this thing. Okay, so I think I'm done with this. So today I think we are good with this presentation. So if you have any questions, you can ask. Do you have any questions? Anybody has any question? Nobody has any question? Okay. Yes. Namika, I think you are not audible.
No, I'm not saying anything.
Okay. So no questions, Shobha?
Mm.
That's great. No question is so super. Super way of being intelligent. Stop recording.